So, Alicia Wain is a senior botanist and plant ecologist with the Queensland Herbarium and a bioregional coordinator for the Brigalow Belt and Central Coast bioregions, Central Queensland Coast bioregions. She's worked extensively throughout Queensland, and prior to her work with the Herbarium, worked in the private sector with a focus on the management of threatened flora impacted by large-scale infrastructure development. We've also had a bit of a conversation about that this morning. She has led numerous threatened species and offset programs, including 9 successful translocation and management programs. So Alicia's going to talk to us about the outcome of those Cycad translocations. Thank you.
Thank you. Yes, more Cycad talk. Okay. So I have talked about the actual individual programs in the past. So today I'm just going to talk about the approaches that we took and the outcomes that we got from that, and then all the lessons learnt and the challenges that we faced. Okay, so in Queensland, we've got 47 species of cycads known to occur in habitats, and then 39 of those are considered to be endemic to Queensland. Of those endemics, 14 are estimated to have 3 or less subpopulations in the wild. 6 of those are estimated to occur as a single population, so there's no subpopulations anywhere that we found. And the survey effort to date suggests that 11 of those species have at least one subpopulation that's unlikely to be viable in the wild. That includes 5 endemics that are currently of 4 or less subpopulations in the wild. Targeted surveys have confirmed that some of those species are no longer present at previously recorded locations, and that is independent of impacts from development and so forth. And most species are currently under a status review. So in terms of protected areas, 70% have at least part of a subpopulation in a protected area. However, there are 11 endemics that currently are not known to occur in a protected area. In terms of development pressures, we have 13 endemics that are currently within active large-scale development footprints. 2 of those species are subject to 9 different development footprints. And by 2027, the same subpopulation of Cycas megacarpa, which is subpopulation 8, will have been impacted by 13 different projects since 2009. So this is an overview of the projects that we're covering at the moment. So you can see the first 3 projects are for Cycas megacarpa, all within subpopulation 8 and all within the Callide and Calliope ranges in central Queensland. Project D is a little bit different. It's Cycas ophiolytica, and that's covering subpopulation 6, just a small number were salvaged at the northern end of its distribution range. So, Cycas megacarpa, it is endemic to Queensland. It is listed as endangered under both the Commonwealth EPBC Act and the State's NC Act. Its distribution range does not overlap with other cycas species, and it generally occurs just north of Gympie to just south of Rocky, and always within 100 kilometres of the coastline. We do believe that there are 36 subpopulations, however only 2 of them are believed to be significant and viable in the wild in the long term. So we need further survey effort to try and find some others. For ophiolytica, it's a bit shorter. It grows to 5 metres tall. Again, it's endemic to Queensland. It's listed as endangered under the EPBC and NC Acts. Its distribution range does not overlap with other cycas species, and it starts to occur just south of Rocky to just south of St Lawrence in central Queensland. It's known to have 10 subpopulations, and again, only 2 of those are considered significant and viable in the wild. So in terms of our approach, all of these projects were associated with development impacts. So lots of surveys were done, both within the disturbance footprint and the appropriate buffers, but then we also needed to understand what the actual impacts to the subpopulation would be. So we started looking at extent mapping and population viability assessments. From there, we then developed a Cycad working group to maximise the likelihood of success, and that brought through a lot of specialist expertise, and that also helped us to identify where the research priorities needed to be for the species. From there, translocation management plans were developed, specifically with methodologies for how to do everything, and we of course had regular consultation with state and Commonwealth agencies. So in terms of the surveys, we covered 1,800 square kilometres, both aerially and on the ground. We did target specific community types where we believed that there was suitable habitat for the species. There was a number of parameters that we covered when we were assessing, and there was also a number of constraints, particularly around landholder consent, which I'm sure everyone's aware of is a problem, and accessibility. Generally, this species likes to occur where hiking in is your only option. When it came to the translocation management plans, we used the translocation guidelines that ANPC developed back in 2004. And then we also took all of that amazing knowledge that we got from the Cycad working group, and we developed detailed methodologies on how this was going to happen to give us the best chance of success. When it came to translocation preparation, baseline assessment and tagging was the key thing, and it started around a month out prior to salvage activities. All of the individuals were tagged with a unique identification code on a fireproof tag, and all the core data was captured. For the seedlings, if we knew and could confirm the maternal parent plant, we also attached that data to that individual so we could track it for its life. In terms of recipient site prep, weeds and pest animals were removed from the immediate vicinity. We set up all the fire breaks and the watering systems. The temporary tracks for watering and maintenance, they needed to stay in place for the life of the program. Cattle proofing was a big thing as well, along with gates. And then the planting layout was last, with hole prep and stake placement. We had to adopt a number of different translocation methods because of the terrain that we were dealing with. So hand digging, particularly when you had the steep slopes or the range faces, was the only option that we had, particularly from an OHS perspective. We did use mechanical equipment, but only where the topography and OHS allowed. We did use helicopters as well, particularly on the range face, so that we could safely get those plants down into the landing area. Any damage that occurred to the plants as a result of the translocation process was recorded and photologged and put into the database. And that did also, not only did it help us identify the horticultural requirements for the plant, but it helped us track its progress. So if it did die, we could go back and we could look at what happened to that plant, and we could take it as lessons learned and move forward. In terms of monitoring parameters, this was all applied to the temporary storage, the permanent recipient site, and the reference sites. And some of those key parameters I've got listed here. So when it came to frond growth, if we were seeing stunted early new growth, or if we were seeing repeated early senescing growth, we knew that the root development was still not happening at the rate that we wanted it to. When we had trunk condition and pup development, if it was producing a lot of pups, we knew it was still undergoing a lot of translocation stress. The development of reproductive material was a key parameter as well, particularly when it came to the number of seeds that might have matured and if they went on to sustained recruitment. The presence-absence of invertebrates, not just pollinators, but also just opportunists and predators as well. And then the degree of foliar attack. So all in all, we had 607 that were directly transplanted into their recipient sites, and 716 were salvaged, but their offset site wasn't ready yet. So they were taken to a temporary storage facility and they were held for 2 to 5 years. We also did a pilot program for 309 individuals, all juveniles, and they were planted into the permanent recipient site in 2015. So this is all of the projects combined for the survival rates. You can see there's a bit of variability there. So for year 1, 81 to 95%, totally within the realm of expectation that we had. By year 5, 67 to 80%, again within that expectation that we had. When we put it according to age class, the seedlings, 53 to 91%. What we found was the seedlings benefited from being taken out of the wild and put into nursery conditions for the first 2 to 3 years before they were planted into the ground. When you look at adults at 64 to 84%, we found that the reverse was true. So put them straight into the ground, they fared much better than what they did in temporary storage. Uncontrollable events. Okay, so fire. We had a wildfire impact project B 1 week prior to salvaging. So we were really glad that we had fireproof tags on those plants. There was also a planned burn that extended from one offset site that they were prepping, and it moved into an adjacent offset site. So that was a communication issue, and we'll talk about that in a minute. Cyclones. We had 2 cyclones go through during this program. We had Cyclone Oswald in 2013, and we had Debbie in 2017. We also had record-breaking rainfall, which was just an insane amount of rain for January and February. We also had a dry storm. It had everything but the rain, but the wind actually caused the trunks to snap off on some of the adults in temporary storage. Challenges. Okay, so it wasn't all bad, but ultimately the projects weren't concurrent. So if we did something not as great as we could have in the first one, we learned and we continued to improve with each project, which was great. However, there was limited collaboration and communication between the parties, even if you had the same people working on multiple projects, there were so many confidentiality clauses and it was so compartmentalised that often communication flow was not the easiest. The works were also undertaken when legislation and policy around offsets and threatened species was in a state of flux. So this meant that every project was assessed differently and every project was given different approval conditions. So that was something we had to work with. There was also limited guidance with respect to monitoring a species like this, and how did that work when it came to a price-driven versus a conservation outcome? Because obviously development and conservation don't always meet in that space. Other challenges, geology was a big thing, particularly on the range faces. It forced us to go very slow and often things had to be hand dug. So we had to deal with the OHS requirement of that as well. Male-female determination. So this is important, and generally we only know it for less than 20% of a subpopulation that we're dealing with. Because we didn't have that baseline information, we couldn't tell if they were changing sex as a consequence of translocation stress. But it also affected our planting layout, so that made things a little bit difficult. There was no requirement for salvage seedlings to be taken off-site and grown for 2 of those projects, and the survival rates are fairly evident of that. And Project D had a fantastic landholder. He was happy to provide the recipient site for free, even excluded all the cattle, but he allowed competitive mountain biking within the recipient site. So we had to work around that. So in terms of lessons learnt, I've said it before, communication flow is really critical. The material of the bags and the size is really critical. So the thing to bear in mind is that, yes, these plants were only meant to be in temporary storage for a few months, and some of them ended up being in storage for 5 years. So we had to keep accommodating all of those changes, which was not the easiest thing to do. Transplanting directly into the recipient site does provide better outcomes for the subadults and the adults, but not for the juveniles on the early end and not for the seedlings. Fireproof tags go on fireproof stakes. That's all I can say about that. I know people will try to be more cost effective than using fireproof stakes, but I really cannot reiterate it enough. It needs to go on a fireproof stake. Thank you. Observations. Plant spacing is really important for viability and dispersal. So we worked out that a minimum of 6 metres. So even if you had cycads within your in situ recipient site, you still wanted them planted 6 metres apart. And because they don't really have dispersers anymore, you needed to allow for that future recruitment in the site. If you planted them all next to each other, it was not going to work. Seedlings, if they're within 1 metre of the maternal parent plant, they will be dead within 2 years. So you need to account for that. Development of reproductive material. The pollen cones, sometimes almost instantly, but they would develop within 12 months post-translocation, irrespective of where they were. Females, we got no seed development until they went permanently into their recipient site, and even then it took at least 5 years for them to develop. Sustained recruitment, though, we did not observe until 7 years post-translocation in situ. There was a high degree of subsurface variability within the number of pups below the surface. So even if you thought that you had a seedling or a juvenile, you didn't know that it could have been a mature specimen that's just lost its stem and started to resprout from the base until you started to dig. The coralloid root, which is how the plant fixes nitrogen, can grow up to 1 metre from the stem. So you needed to consider that when you were digging it out. Sometimes it got damaged, sometimes totally destroyed, but it does delay its survival rates and progress if you do damage it. You cannot accurately measure the height of the plants through cataphyls and height, of the age I should say, through cataphyls and height. Dormancy, fire, stem breakage, they all impact on those measurements. And so it was really critical that we had to find a better way to do it. So when it came to developing reproductive material, they needed to exceed 50 centimetres in surface height. So if they lost their stem and then had to resprout from the base or went below 50 centimetres, or if there was sediment deposition over the top, they would not produce that material till they reach 50 centimetres again. For Cycad, we found that to be 20 centimetres as the case. Horticultural considerations. This is a big thing for the practitioners in the room. So bush rats and possums eat the sarcatester on the seas. So we didn't want to poison them, so that was a key consideration, particularly as the possums do have a minor role in dispersing the seed. Other threatened species might utilise the habitat. We had squatter pigeons move into the temporary storage site and they just stayed there for years. So we really had to consider that. The fronds. The frogs like to live in between them all, and birds will build their nests. So again, how do we treat them with that in terms of chemicals? Redback spiders around the base of the plant and on the plant. So if you're trying to, test out the trunk condition, you needed to make sure that you had adequate PPE on. And funnel web spiders were frequently found within the holes, both when we were digging them out of the ground and trying to put them back in the ground. So the consideration for there was proximity to a hospital, which was often at least an hour away, and the anti-venom had to be chilled and had a very short shelf life. So that was a key thing as well. I don't have time to talk about the unknowns, but there's a quick sighting of them, and that's me.
Thanks, Alicia. Now, write down your questions because there was just so much in there. And make sure you say it's for Alicia, and we'll have questions at the end. But